Okie dokie. So, checking out Chapter 5, BIT 2406, Chapter 5, homework problem number 24. They say that Harry and Melissa Jacobson produce handcrafted furniture in a wood shop on their farm. They have obtained a load of 600 board feet of birch from a neighbor and are planning to produce round kitchen tables and ladder back chairs during the next 3 months. Each table will require 30 hours of labor, and each chair will require 18 hours. Between them, they have a total of 480 hours of labor. Table requires 40 board feet. Chair requires 15 board feet. A table earns 575 in profit. A chair earns 120 in profit. Most people who want to buy a table also want 4 chairs to go with it. Look at that. Most people who buy a table want 4 chairs. So for every table that is produced, at least 4 chairs must also be made. Although additional chairs can also be sold separately. So formulate an integer programming model to determine the number of tables and chairs the Jacobsons should make to maximize profit. All right. So most of this setup stuff is not going to be hard. It's going to be very similar to what we've seen before. The most challenging thing is probably going to be the whole, like, for every table that's produced, at least 4 chairs must also be made. So let's keep that in mind. We're going to call x1 tables and x2 chairs. It's important to recognize that this is not a 0-1 integer model. It's like a what do they call it? Just a regular integer model. So like you can have multiple tables and chairs. It's not going to be the situation that like you either make 0 chairs or 1 chair or 0 tables or 1 table. You can have multiple tables and chairs. So x1 and x2 can be any integer. Let's talk through the initial setups here. So I'm just going to talk through the constraints by hand, and then we'll talk about the Excel thing, and then I'll go on to number 25 as well. So this first one. This is just the number of, the board feet. So there's 600 board feet available. Table is 40. Chairs require 15. So 40 times table plus 15 times chairs is less than or equal to 600, because 600 is all they have available. Next one, number of hours, labor hours, I guess. Each table, 30 hours. Each chair, 18 hours, and they only have a total of 480. So likewise, 30x1 plus 18x2 is less than or equal to 480. Next, the P, the profit. We're trying to maximize profit, and they tell us that we get 575 in profit from each table and 120 in profit from each chair. So simply 575x1 plus 120x2. And now the last thing really to worry about is for every 1 table that's produced, at least 4 chairs must also be made. So we want to think about it like this: like for every 1 table, we're getting 4 chairs. So for every 1x1, we're producing 4 x2s. 4x2 is equal to 4, something like that. So we need to come up with some sort of inequality that relates these two in that manner. So for every 1x1 that you sell, that's going to increase x2 by 4. And then on top of that, you can sell additional chairs without selling any tables. So let's start with the first thing. I'm trying to go back to how I worded it a second ago. So for every 1 table, okay, I got it. As you increase x1 by 1, your x2 will go up by 4. As you increase the tables by 1, your chairs will go up by 4. Think about that as an equation. If like x2 is your y and x1 is your x, think about slope. As x1 increases by 1, your x2 should go up by 4. And so x2 is going to be equal to 4 times x1. The number of chairs will increase by 4 every time you increase your tables by 1. And it's important to think about how the number of chairs will not just be equal, to 4x1 because you can still make more chairs after that. So really the number of chairs can be greater than 4x1 or equal to 4x1 because it can be equal to, or you could make more chairs, so greater than 4x1 as well. So let's manipulate this a little bit. I'm going to just turn it around. So it's 4x1 is less than or equal to x2. And then to match the Excel document, I'm going to subtract x2 and have it less than or equal to 0. So this is the constraint that comes out of the whole 4 chairs per table deal. Okay? Now, let's look at Excel and compare our work. Compare notes. Again, profit per item, table, chairs, pretty straightforward. Number of, like the amount of wood is the whole board feet, 600 board feet. So there's a 600 available. This is the amount per table and chair. Labor in hours, 480 available. This is that labor per item. And then table requirement, check this out. I think they did it right here. Look at this equation here. Let me pull this back up. They said C9 times C12, that's the number of tables, or sorry, it's table requirement. So it's 4 times the number of tables minus 1 times the number of chairs. So 4 times the number of tables minus 1 times the number of chairs, right? And then we'll see in the solver that they set this less than or equal to this 0 here. So less than or equal to this 0 here. Hopefully it's clear that the usages for these are simply like this times this plus this times this. Same thing here. This times this plus this times this. Okay. Pretty straightforward. Hopefully we go to solver. Our max we're trying to find is from the profit. Again, profit's just going to be this times this plus this times this. And then the changing variable cells are just the number of tables and chairs. And then watch what they did. They did all the F 7 through 9 here less than or equal to what was available. So for these first two, it hopefully makes plenty of sense. But for this last one, this -4 is a result of doing this right here, the written left side of this inequality. And they set it less than or equal to 0, which is right here. Okay, and then they made sure that these two numbers, the 4 and the 20, were integers. The number of tables and chairs were integers. Let's talk about that real quick. So I realized earlier, you don't literally set it equal to integer, because I was like typing an integer and that did not work. What you do is you choose the cells and then you just click on int. Okay? And that sets it equal to integer. Okay? So then when you solve, you get this. You find 4 tables, 20 chairs, profit of 4,700. That's all there is to it. That's the whole problem. Let's pull up number 25 here. They say the Jacobsons in problem 24 have been approached by a company that needs a wooden stool for its catalog. They've asked them to produce a batch of 20 wooden stools. They would get 65 per stool profit. They would use 4 board feet of wood, and it would take 5 hours to produce each stool. They say formulate and solve the model to help them determine whether they should also produce the stools. So as a reminder, or just to think about it now, the profit for doing just the tables and chairs is 4,700. Now I'm going to show you what it would look like if we manually input the stools to this scenario here. So what I did was just copy this, and I added stools, a column for stools. Profit is 65 per stool. The wood is 4 per stool. The hours is 5 per stool. I had to, of course, adjust the usage. The usage right here to this times this plus this times this plus this times this. And then same thing for the usage for the labor. Table requirement does not change because table requirement is only between the tables and the chairs. You don't need to worry about the stools for that. Now what I did is going to be different than the answer key is 25, the like Excel thing y'all were given. So we'll address that in a moment. Tables and chairs are going to be the changing variable cells. But stools, what I did, since they've only asked us to produce 20 stools, We're not producing less, we're not producing more. We are either producing 20 stools or we're not, I guess. So I took the approach of like, let's set stools equal to 20 and see what the profit would be, and then compare it to the previous profit of just doing tables and chairs and see if it makes more sense, see if we make more money, more profit by doing the stools as well. So let's look at how I modified the data solver here. Profit is still what we're maximizing. I guess also I changed the profit equation so that it included the stools as well. Hopefully that's clear. Maximizing profit. I left the changing variable cells as just the tables and chairs because I've locked in the stools at 20. And then C12 and 13 were integers, locked that in. And then I think all the same stuff, I've just set all of this less than or equal to the available. That's pretty much it. And then when you hit solve, you get 49.45. That's your new profit if you make the 20 extra stools. And previously with the tables and chairs, we had 4,700. So if you make the 20 stools, you're getting an additional profit of like $245. So what that tells you is you do want to also produce the stools because you'll make a few extra $100. Okay. Now let's look at what they did for 25 and just address it a little bit. I don't fully understand it, but notice it's like way more complex than what I did. So like, it doesn't have to be that complex to find an answer. Like, if it comes down to it, I don't know what they did entirely. So it's like produce stools, ones or zeros, I don't know. Stools, 20. I think, so they made like all three of these, the changing variable cells. They did all the same stuff I did, I guess, with these first three. Leftover. I don't know, we didn't worry about leftover. But look what they did. They did like stools and then select. I don't know, I guess it's a matter of like, I don't know. It's like they were including something that was going to calculate like including the stools or not including the stools. Whichever one would give you like a better profit, like a higher profit. I don't know, they somehow incorporated that and it made it like so much more complicated with like ones and negative 20s and 20s and ones. And I don't know, personally I don't think that was necessary, but this is how they did it. Yeah, I don't know, I don't think I can honestly fully explain it, but the slight difference that I can tell you is they've made all three of these, tables, chairs, and stools, the changing variable cells, as opposed to where I just made the tables and chairs the changing variable cells. I'm just going to say my way was much easier to understand. I can't even fully understand this, but that's about all I know about this. I hope that helps. All right.